Hi and welcome to another very exciting tutorial. In this video we're going to build and understand a cool machine learning project based on decision trees, which we will build in a matter of minutes. So the goal of our project here is to be able to select an age and gender, and the ML model predicts the favorite emoji that is associated with that group of people. So if you want to see how this is done in practice in VS Code, just skip ahead, and if you want to understand the machine learning principles and the mathematics behind that, just continue on from here. So this is the actual data that we will be using for this little project. It is a simple CSV file that you can download from the video description below, and I have displayed it as a table here. It contains age and, for the purpose of this tutorial, simplified gender data where 0 means male and 1 means female. Based on that data, we want to create a decision tree that predicts the favorite emoji of a specific age and gender group. Decision trees are a so-called non-parametric supervised learning method used for classification and regression. The goal is to create a model that predicts the value of a target variable by learning simple decision rules inferred from the data features, and the tree can be used as a constant approximation when you move along its paths and nodes. So for example, if you have a look at this tree that is generated from our data, you can see that the condition that is specified on top of one node is age, which is below 19.5 years. So if this is true, then we will most likely see this class or this emoji as a result or as a prediction. But if this is false, we move along a different path and come to this node where we'll now have to distinguish between gender, or we have this condition that gender is less or equal to 0.5, and if this is true, then we move along this path, and if it's not, we move along here, and so on and so forth. And this tree goes on for a bit. We will have a look at this and the process of creating such a visualization in code later on. But what is interesting here is actually the second value we get here, which is the so-called Gini impurity, which you can see is at 0.72 in our first node here, and that goes down here as we move along these paths, reaching 0 if we hit the end of a path. So we're going to explore what this is now in detail. And in non-mathematical terms, think of the Gini impurity as a way to measure messiness in your data. If every item in your data set is in its correct group, like in this visualization, like all purple circles are in one glass and all blue ones are in another, then the Gini impurity is 0. We have no messiness, so very pure data set. But if things are mixed up, so the purple and the blue ones are together in one glass, the Gini impurity increases and the impurity is high. And we can use a formula that gives us a precise way to calculate this messiness based on how mixed up the categories or classes are in your data set. So if we look at that in a more mathematical way, then we can say that we try to find the Gini impurity of a data set we call D. So what we're trying to do here is summing up the squared probabilities of each class. So what we have here is the probability of an item being classified into the class I, or in simpler terms, it's how frequent a class is in the data set. For example, if half of our data is class A and the other half is class B, P for class A is 0.5 and the same for class B. And this is now the actual probability squared, which is a way to give more weight to higher probabilities. And finally, we're subtracting the sum from 1, and this gives us the impurity. So a Gini impurity of 0 means all elements belong to one class, so it's perfectly pure, and a higher Gini impurity means the data is more mixed up or more impure. So looking at that now in the context of our decision tree visualization, the Gini impurity ranges here from 0, somewhere between 0 and 1, where 0 indicates that all elements in the node belong to a single class, so we have a pure node. And higher values closer to 1 indicate that the elements are randomly distributed across various classes. So when a decision tree is being constructed, each split is made in a way to decrease the Gini impurity, and the goal is to create nodes with lower impurity, which means that the elements in these nodes are more likely to belong to the same class. Or again, in other terms, when we are trying to split the data, we want each group after the split to be as pure as possible, so having mostly the same color or emoji, or in more general terms, class. And at each step, the tree algorithm chooses a split that decreases the Gini impurity the most. And after several splits, you ideally want to end up with nodes that have low Gini impurity closer to 0, meaning the elements are mostly the same in the class. And as for why we are using decision trees for our problem, we can have a look at 3 major things. First of all, the handling of categorical output. So decision trees are well suited for classification problems with categorical output. They can easily split data based on categorical features to make predictions on a limited and usually fixed number of possible values, like in our case, the different emojis that would be preferred at different ages and with different gender. The second point is that we can create very understandable models because decision trees provide clear visualization and understanding of how decisions are made, which is very beneficial for analyzing how age and gender affect emoji preferences. And last, we have the possibility to work with nonlinear relationships, which means if there are complex nonlinear relationships between age, gender, and emoji preference, decision trees can capture these effectively. And with all of that said, let's now have a look how we can use that knowledge very easily without having to worry about actually writing all those algorithms on our own using some very interesting Python libraries like pandas and scikit. Now that we've covered some of the theory behind decision trees, we can move on to create our actual project. And this project, as I said earlier, contains an emoji data.csv file, which you can download from the video description below. And this is not real world data, it's just constructed for this tutorial. You could also create some data yourself if you want. I've already set up a small project called Emoji Prediction in VS Code. We're going to have a look at these other files later. This is just to display some of the things that we're doing. We're mainly going to work with a Jupyter notebook here in VS Code. So to create one, if you're having the extension for that, you can just press Command-Shift-P and then hit create new Jupyter notebook. I'm going to save that as our create model notebook. And if you just want to write that into a Python file, that's fine as well. So before we actually write some code in Python here, let's install the proper libraries and also maybe create a virtual environment for our project. So I'm going to use Python 3 here, the module flag, creating a virtual environment, and then let's call that maybe emoji prediction, or abbreviated pred, and create that library. We can then change or select that for our workspace, which we're going to do. Now that we've created our environment, let's quickly activate it using the source command. Then we use our emoji pred environment bin and activate. And now we have entered this environment, and now we can install our libraries, which are first of all pandas, which we will use for things like data frames and so on. We'll also use scikit-learn, which includes, for example, our algorithms that we're going to use to create our decision tree. We're going to need joblib, which we will use to export our model to a file. And last but not least, we're going to install Flask, which we are going to use to display our website and also create a little API around this whole system. So once we have installed all of that, we can go ahead and open our notebook here, and we will start with importing pandas as PD quite traditionally. We'll also, from sklearn, use tree and import our decision tree classifier. Also from sklearn, we will use model selection and import train test split, which I'm going to explain shortly. And then we will also get sklearn and metrics to actually import accuracy score, which we're going to use to actually determine the accuracy of our model. And as I said, to export our model, we use joblib. And from sklearn, we will also import tree, which we can later use to actually visualize our decision tree. Now, to actually get started, what we can do and have a look at our data, we can actually create an emoji data object here using pandas, and just use this very handy function called read CSV and read the emoji data .csv file. And if we have a look at the emoji data, just clicking on the execute cell and below, and use our Python environment and use our emoji prediction, then we can just install the required packages. If some are missing in our case, we also have to install the Jupyter extension here, and then we can import, or VS Code imports all the necessary libraries. And as soon as this is done, we can actually display our data right here. So this is the data from our CSV that we can work with now. And now the interesting thing is, when we work with that data, and if we're working with a classifier, which we're going to use, so as I explained earlier, we're going to create a classification, or we have a classification problem here that we want to work with. And the actual input data set that we're working with is age and gender. And we want to actually use this input data, or this input data set, to actually create an output data set, which are the emojis, which are the answers that we want to predict. And traditionally, if we split our data now into actually two if you want, data frames, then what we can do is, first of all, define a variable x, which uses the emoji data, and we will simply drop the column emoji from that, which gives us the input data set that I just talked about. And traditionally with y, we use that as our output data set, which just needs the emojis that we use. And therefore, let's use, again, emoji data, and just access the emoji column here using the brackets. So once we have that, we can quickly have a look at X, for example, and see, as you can see, we dropped the emojis column here, and with Y, we only have the emojis column, and with that, we've prepared our data to continue working with that. And followed by that is now that we actually want to create a training testing data split. So what that means is that we're actually using kind of 80% of our data to actually train our model. And then we will use 20% of this split to test the accuracy of our model. And then we will have a look at the accuracy, export the model, and so on. But for that to start, let's create some of these variables. We will use xtrain and xtest, and we will also create ytrain and ytest, and then use train test split, and just pass along, as you can see, first of all, our input data set, then our output data set, followed by actually the split ratio that we want, which we can define using the test size parameter, and this is going to be 0.2 in our case, so that we use 20% of our data to actually test the model. And with that being done, we are now actually ready to create our decision tree classifier, just calling it model, and using the decision tree classifier that we got from scikit. And now to actually train the model and do everything we actually talked about in the theoretical part of that tutorial, we just have to use the model and call the fit function and pass along our training data, and that's it. So we input the input data set, and we define our output data set, and this is what our model is now trained on. And now we can actually already test our model. Let's maybe create a prediction variable here and use the model and just call the predict function. And now we just have to pass along a 2D array here. So using 2 square brackets. And then we can define what we're actually looking for. So maybe let's say someone who is 14 years old and female, which we can indicate by just specifying 14 and 1 for the gender, 0 being male, 1 being female. And once we actually create one prediction or add prediction here to create an output, we get a first prediction here for the gender and age. If we now turn that up to, let's say, 30, then this changes to another emoji and 25 or 24 as well, and maybe change the gender here. So this seems to work. Now, to actually get a proper calculation of the test score that we can create, let's just create a new prediction using our model and predict function again, and then pass along our input data set or our input testing data set. And then we can use another variable, call it score, use the accuracy score function, and then use our output class or output data set that we want to use for testing. So ytest, and also the predictions that we just made. And then we can create an output for our score. As you can see, we get a score of 1 here. And while a perfect accuracy score seems ideal, it's actually quite rare in real-world scenarios. It can sometimes indicate that the test set was too easy for the model or not diverse enough. In the case of well-known data sets, models often achieve very high accuracy because the data set is relatively simple and well understood, and as in our case, it is also very simple. So this just for actually creating the test that you can perform to see the accuracy of your model. Now, if we actually want to see what our model looks like and see a visualization of our decision tree, we can create just .data as a variable here and use tree, which we imported earlier from sklearn as well. And there we get a function called export graph vis that creates .data that we can actually visualize with an extension in VS Code or somewhere online. And what we need to do is pass along our model an out file or an out file name, which I'm going to call emoji result ... And then we have to actually pass along the feature names that we want to use, which in our case is age and gender. We can also pass along the class names that we want to see, which in our case we can get from model.classes_. And then we can also say that we want to see all labels. We want this to look a little bit nicer, so we set rounded to true and use fill colors, so we can set this filled parameter to true as well. And if we now run this, you will see in a second that we get actually emoji result ... here as a file in our project, and with the proper extension for GraphViz installed, when we open a preview here, then you can see a visualization of the decision tree that was created using the decision tree classifier. And as you can see, as we talked about in the theoretical part of this tutorial, the Gini impurity just decreases along the path, which is achieved after each split, and by that getting a classifier that we can use now actually for our little web application, which we will create really quickly. You can also create that in ChatGPT very fast if you want. But what I did here was using Flask. So I created a templates folder in my project, created a form.html file that has some CSS here. And what we do here is just creating a form using a slider to determine the age that you're looking for, creating 2 radio buttons for the gender, a submit button, and then also get a label, kind of label to actually see the prediction using some conditionals here from Flask. And we're using that as a template in the API Python file that we have here. And what we want to do now that we have all of the necessarily machine learning stuff done is actually use our model in this API. But to do that, we actually need to export our model into a file, which we can also do again in our Jupyter notebook. And therefore, let's just add one last file. We can use joblib, use the dump function. We want to export our model, and we call it emoji prediction or emoji predictor .joblib, and run this one more time, and then we actually get this joblib file right here. And now we can go back into our API, and after we created our Flask app, we're going to create a model variable, use joblib again. Now the other way around, we use the load function and load emoji redictor. There is a small typo here, .joblib. And then what we also need to do, as you can see, we get the data from the form. We want to render the template using the form.html file. And when the function predict is called using the predict endpoint of our API, then we get the data from the form. We create a prediction using the model, call predict, using pandas to create a data frame and initialize it with our data we got from the form. And once we did that, we can actually render the same form template, but with the prediction results. So we return render template. We make this with the form.html, and prediction equals prediction as a parameter right here. And now that we did that, we can actually run this and get the warning that this is a development server. And once we open that in the browser, we have our small application here. We can select an age, select a gender, predict, and we get an emoji right here. Let's just change that a bit and see some of the results. And I think this works quite nicely right here. And with that, you have created a first machine learning application in really a matter of minutes. If you just write the code, I'm sure you will be able to do it in 5 minutes. Thanks for being here. If you want to see how to use such a model in an iOS application, then let me know it in the comments below. Also, if you have any further questions, let me know it in the comments below. And in any other case, stay tuned for more AI and machine learning content in the near future. I thank you so much for watching, and I'll see you in the next one. Bye.